Our next presenter this afternoon is Alee Knoell. Alee is a biologist at the GTM Research Reserve. Having harbored a vast love for the natural world at a young age, along with a strong desire to preserve and play a part in its conservation, she received her bachelor's in environmental science at the University of Central Florida. During her time in Orlando, she interned with the Orange County Environmental Protection Division, focusing on aquatic vegetation. And while at the reserve, she has spent her time working on various research projects with a primary focus on oyster spat monitoring, which Alee will be sharing about today in her presentation. So Alee, we can turn the virtual controls over to you.
Thank you so much for that introduction, Caitlin. Let's see if I do good with these controls. Here we go. So as Caitlin mentioned, today I'll be talking about oyster spat monitoring in the Talamata, Matanzas National Estuary Research Reserve. So first of all, what are spat? Well, spat is the collective term for oyster larvae once they have settled on a substrate. So oysters are broadcast spawners, meaning that they spend the first part of their life cycle as free-floating fertilized eggs, and that is followed by a 2-week period of swimming through the water column. And then once a substrate is selected based on a number of chemical cues and environmental factors, they are thus referred to as spat, and they remain there for 1 to 3 years, or they remain there for a while, but they reach maturity in about 1 to 3 years. In this little yellow picture to the left here, we have one of them featured under the microscope. Now, what is the importance in studying spat? It's important to understand the changes undergone by oyster populations spatially and temporally. And also, it can give us some insight as to the opportune times to establish artificial reefs. So knowing when the oyster larvae are looking for a home and where they are in the most abundance really helps to encourage the foundation of these artificial reefs and potentially lead to their success. Something else I want to circle back to is to talk about the importance of oysters in general. I mean, they provide a number of ecosystem and economic services. They buffer against storm surge and wave action, and they aid in preventing erosion. They serve as habitat and food source for a myriad of estuarine organisms. And also, as Daniele was talking about in his last presentation, they filter water. They can filter up to 50 gallons a day, which I can't even finish a glass of water sometimes, so it's kind of insane. But aside from all that, there's also the cultural aspect. If you tuned into the Heritage Monitoring Scouts presentation yesterday, they referred to some shell middens that are present on our coast. And finally, we eat them. Some people eat them, so there's another reason to keep them alive for you. So the GTM kicked off this monitoring program in 2015 as a supplement to the oyster monitoring. We have 5 regions in our intercoastal waterways, the northernmost being the Talamata River and Guana River, going down into St. Augustine and Salt Run, and then our southernmost region is Fort Matanzas. And within each of these regions, we established sites. We have 17 reefs, so there's 3 to 4 reefs per region. We selected healthy oyster reefs to insert our spat trees, which are PVC tees that suspend our shells. Now, the goals of this project, as mentioned earlier, are to determine oyster settlement dynamics, gather baseline information for oyster reef restorations projects, such as the Wright's Landing Reef, which is pictured to the right here, and to keep interesting parties such as local harvesters, citizen stakeholders, regional resource management, and then the scientific community like yourselves informed. Now, the first step in all of this is to get the shells cleaned. So we soak all of our oyster shells in bleach water for 48 hours. And then following that soak, we scrub and chisel all that excess residual stuff off. So the barnacles, spat, algae, my blood, sweat, and tears, pencil marks, all of that comes clean off of it so that we don't have it on our shells for the next deployment. And then following that process, we soak them again for a minimum of 24 hours. Now, once they're all clean, we string 6 shells on galvanized wire, and the top 2 are discarded, they're buffer shells, and the middle 4 get processed. And with all those stringers in tow, we go out to each of our sites and we do the exchange. So we take the shells that have been out there for about a month and we replace them with our squeaky clean shells. And another method that we have included in our spout monitoring as of fall last year is bringing out a YSI handheld device and dipping it in the water at each of our reefs to gauge water temperature, dissolved oxygen, pH, and salinity at each reef. Now, our processing methods have actually changed quite a bit over time. At the beginning of this monitoring project, we were using a magnifying glass to look at both the inner and outer surfaces of the shells. But as you can see in our picture on the right here, we're looking at some tiny little organisms. So we switched over to using a microscope to make sure that we're getting everyone present and accounted for, and even the ones that are barely, if at all, visible to the naked eye. Now, our next refinement was that we stopped counting the outer surface of the shell, as past research and our own experience has shown that spat really tends to favor the inner surface. So now we're just looking at that smooth inner side of the oyster shell underneath a microscope. Throughout all of these changes, we have had the diligent help of volunteers, which I would to thank all of the ones that I know are present here today for helping. And the 2 years that I've been working on this project, if I didn't have volunteer help counting these guys, I would have ripped my hair out and cried a lot. There's a lot of spat, as we will see. And our final refinement, also, we have a correction factor to account for this switch in methods to try and keep our data all squared away. And the final refinement that we have faced is that of COVID-19 inducing in-house processing. You can see in this middle shot, my cozy little workstation. It's functional, maybe not the most sanitary, but you gotta do what you gotta do. Now onto the good stuff. So this graph here illustrates our monitoring from the beginning of the project in 2015 to the end in 2020. Now we see our spat per shell averages per region. Each black line is a different region. This tall one here is Talamata, and then our lower ones are not very distinguishable in this graph, but the main takeaway from it is this annual increase. So we started off barely even in the double digits in 2015, and then slowly working our way up to where spat abundance was very, very high. Spat per shell averages reaching over 200 in some regions during peak settlement. And another takeaway from this graph that we can see is we really don't see this high settlement in winter months. So our peaks, our highest abundance are going to be once we get into the summer and especially the fall season. And with the exception of last year, we really weren't seeing any settlement following October. Spat were also feeling weird in 2020, I guess, because their November settlement was higher than usual. And finally, we notice a great deal of variation with between our regions here. So not all of them are on the same page as far as when they're going to peak, when they're going to have their small spring peak and how much that is going to be present per shell. There's also some among region variability. So Guana River is a really good example of that. Each of these pink lines represent the different guana reefs. And you'll notice that they all seem to dance to the beat of their own drum, especially in 2017 through 2019, we noticed a lot of variation in when their minor peaks are going to be, as well as the magnitude. 2019 is the clearest exhibition of that. You see our top one here is going to be our reef that's at the mouth of the river. And then in that very same month, you have almost 200 spat per shell average, on average, less in our reef that is closest to, or that is farthest from the mouth of the river. Now also, we have the most abundant spat in the Talamata region, which is exhibited by this teal line here. So since its introduction in fall of 2015, it is had consistent higher spat per shell averages than all of the other reefs. I think last year, one of the highest spat numbers I counted on a shell was in Talamata, and it was like 600 something on one shell. So Talamata really produces a lot for us. within this region, the two reefs that really carry the team, so to speak, are our Wright's Landing reefs, as featured in one of the first slides. They're shown here in teal, and they're actually constructed reefs. So our natural reef is shown in black, and you can see that it really doesn't yield as much spat as the rest of, as the other two constructed reefs. So moving on. So now we circle back to the YSI that I mentioned in our method section. This here is the temperature graphed across the year for each region. We can notice that it is pretty low in the winter season. So January, February, it's not really very high. And then it starts to creep up in March, reaching a slight peak in April, and then seeing a bigger peak in July, and going back down in the winter. And that's all pretty intuitive for anyone who goes on the boat or at the beach or anything. The water is cold in December. The interesting part is graphing the average of all those black lines, so just the water temperature that we gauge throughout our region against our regional spat graph. So the water temperature is shown by the black line there. You can see that each of its peaks, the minor one in April and the bigger peak in July, is followed by a peak in spat settlement. So that implies that water temperature may have an effect, may have some sort of implications towards spat reproduction. And so we're maybe seeing that the next couple months with our spat settlement on our stringers. So to sum it all up, spat abundance has been increasing annually. We were able to watch it grow from 2015 to 2020. There's been variation in minor peak timing and abundance between and among our water bodies within the estuary, within our study sites. And also the Talamata River stringers have consistently yielded the highest spat counts within that region, the two constructed reefs yielding the highest amounts. And then finally, temperature may influence spat settlement. So like as we saw, it was highest a month or two before the spat peak. So that could have something to do with that. So next steps, the future of our monitoring, we've already reduced the frequency. It has been 2 months now since my last spat adventure, and I'm not gonna lie, there's a bit of a void in my work life, but I don't miss seeing them in my sleep. We're moving forward from that. We can use it though for site-specific pre-restoration monitoring events. So if we want to learn more about a specific oyster reef, get into the nitty-gritty of its dynamics, we can look through our methods and look through our data and go from there. And also, if we end up wanting to go put out an artificial reef before just going out and putting it anywhere at any time, we know the right season to do it, and we can even set up a spat tree to see if that would even collect the spat to build upon that foundation and keep it present. And then also we can do this monitoring to evaluate acute events such as storms and die-offs. And then finally, applying this water quality data. So I got started with the temperature, and we got a nice little graph out of that. But as I said, there's dissolved oxygen, salinity, and pH still to look at. And we could probably go further with temperature as far as just seeing any connections or correlation between those parameters and spat settlement. And that is it for me. If you all have any feedback, it is more than welcome. And any questions, I will do my very best to answer.
Thank you
Thank
so
you.
much, Allie. We do have several questions in the chat box. The first being, it looked like the peak settlement of the spat has shifted to later in the year. Do you have any idea of what's causing that shift?
So we have noticed that shift. It could be sort of a cycle. I've read in past literature, I cannot remember which one it was, but there was a paper that did a spat study, I think in Georgia, and they had every year it would shift. It kind of would start in May and then be a different month and then September and kind of refresh. It could also correspond to our switch in methods. So we might not have been using the microscope at that time, and maybe we're missing some smaller spat in that later month. So it could be either of those.
Thank you.
Mhm.
Do you think that you would be able to use the amount of spat settlement to estimate oyster populations?
I'm unsure. I think that it would be really great to look at this spat data and kind of compare it to our oyster monitoring data so we can kind of see if the two do go hand in hand, since we do have reef health estimates from oyster monitoring in general. We could see if spat that accumulate in a reef nearby are more abundant or less abundant and see if it does have anything to do with that.
Great, thank you. Do you think that global warming and warmer waters would bode well for oyster reefs with increasing spat production?
So I don't know. I theorize. I think yes. I do think that there is that positive correlation between temperature and spat settlement. And also, I completely forgot to point it out, but in that first graph, or I did point it out. Sorry, in our first graph, there was that little bump still in November. So we've noticed that spat haven't didn't go down as early as in past years. So they were still settling later than normal. And it'd be awesome if we could compare it to uh, maybe the swamp data and look at water quality and see if there has been a notable temperature increase. And maybe that could be the explanation of that.
Thank you. There are a lot of questions in the chat box.
I know I'm a little nervous.
All right, our next question. With the increase in SPAT recruitment, have you seen any evidence of successful transition to adult stages?
So thank you, Pam. So for that, I'm unsure. I have heard that our reefs are looking better than they were when I started, as far as the oyster monitoring went. But I myself don't really know. I haven't grappled with that data set yet.
Sounds like there's a lot of data to analyze.
Oh, yeah.
All right, and then this will be our last question, and then I'll let you respond to any of the additional questions in the chat box. Are the reefs fairly close to the water quality sondes? And are you guys looking at how swamp data trends could uh, be used on past spat settlement?
Yeah, so they have a data son that they're nearest to. So with the swamp sites, you have Pine Island, which would be nearest our guana and talamato spat trees, and then San Sebastian would be St. Augustine and Salt Run and Fort Matanzas via Fort Matanzas. They're not all terribly close. Pine Island is a little bit further away from Guana River, especially from that one that's far back in the river. So I don't know if that would really give the best indication of water quality, but they're all close enough to where it could allow a little bit of insight. So it would be fun to, now that I have all this time not having to count spat, I could probably give it a whack.
Great. Thank you so much, Allie. We appreciate you sharing the Reserve's oyster spat monitoring data with us today.
Thanks.